When we say that no two fermions can be in one state, or that multiple bosons can be in the same state, the state here is not the quantum mechanical state of the entire system. There are three different concepts which we can call the quantum mechanical state of the whole system, single particle states, which we will use to refer to states of single fermions, and modes, which we'll use to refer to a state that can be occupied by a boson. Consider an analogy suitable for the fermion case. The United States of America has 50 states, and those states have got a capital S. Each state can have a governor. A state cannot have more than one governor. A kind of democratic exclusion principle means that we cannot have more than one governor in a state. Possibly due to some unfortunate tragedy, a state might have no governor at some time. We could write a column vector called the state of the governorships. This state of the governorships column vector will have 50 elements, one element per state, in alphabetical order, for example, with a 1 corresponding to having a governor, or a 0 corresponding to having no governor, in the corresponding element of the column vector. This state of the governorships, the 50-element vector, is analogous to the quantum mechanical state of the entire system, which we will often just refer to as the state with a small s. A state with a capital S, which can be occupied by no more than one governor, is analogous to a single particle fermion state. Consider another analogy, suitable now for the boson case. The United States of America has 50 states with a capital S. Each state can have citizens, with no limit to the number of citizens in a state. We can write a column vector called the state of the citizenships, with 50 elements, one element per state, in alphabetical order, with the number of citizens in the corresponding element of the vector. The state of the citizenships, this 50-element vector, is analogous to the quantum mechanical state of the entire system, which again we will often just refer to as the state with a small s. A state with a capital S, which can be occupied by any number of citizens, is then analogous to a boson mode. Note that we could use the term mode for both the fermion, that is the single particle state, and the boson mode, but by convention we do not usually do that. Here we'll mostly use the terminology single particle states for fermions and mode for bosons, though we will deliberately not use that terminology all the time.